Class, today we are going to see a case study on helical gear failure. Okay, so this is a case study where this helical gear getting failed in a bus gearbox. Okay, usually if a bus gear is using helical gears, so once a helical gear is using, as I already discussed in the class, if in a high speed machine, usually fatigue is one of the one of the main cause of failure for a high speed machine. Okay, so as like the same way gear is used, gearbox running in high speed, maybe it's a possibility that fatigue may be the major cause of this failure. Okay, so here this introduction is that here the gear has been running for 3 years. So the material is AISI A620 steel. So the methods, evaluation method is visual inspection, photo documentation, chemical analysis, micro harness measurement, and metallography measurement. This metallography measurement is that where we are going to take scanning electron microscope is taking the fractographical area, right? So the first one is what are the types of gear failures that can be occurred? Impact,
fractures,
stress fractures. Okay, so listing this part, I have listed first one is as fatigue, is which is because in high speed machine fatigue is the major cause of the failures, right? Okay.
So coming to cause part, so first of all we moving on gear. So with insufficient lubrication, so some of the effects may be occurring that sphere. So surface material removal and leading to pitting and shoring. So the cause of the tooth will be affected in this cause. So coming to next, and pitting surface fatigue. So repeated cyclic and continuously loading. So on the tooth break, so cause excessive shock loading. So excessive amount of load has been impact in the gears, so it will cause, and the effect is incomplete and the tooth failure will be occur in this time. So poor design and gears. So these are one of the cause of the helical sphere failures, and misalignments of the gear. The alignments is not in proper way. So the overload, the excess of the load lead to the tooth damaging and all the causes. So
sometimes it may be due to the surface defects. The last point is incorrect material heat treatment, means that there won't be a sufficiently homogeneous heat treatment. If a heat treatment is done, if improper heat treatment is done, then there will be something like if a food particle is or a food item is cooked improper way, we can't taste it, right? Like that. The same way, if there is an incorrect or improper heat treatment, as a material get failure, right?
So this is in our case. Now we are going to see a case study about a helical gear. The failure which is occurred in a gear is here is a helical gear. Let's see the visual representations of that helical gear. There are some breakings that we can see in our naked eyes. So hence these are the failures occurred, that we can see some pitting and spalling that are occurred in this gear. And let's see the basic parameters of the gears and what are they. The gear is made up of ASIS 8620 steel, carburized steel. Hence as there are given core hardness and then surface hardness. If we consider this gear as a helical gear, the surface hardness will be done in the outer part, which is the surface area, the hardness which is done in the outer surface. Then this is the core part of a gear. The hardness which is in this area is called as the core hardness. So as this gear has a surface hardness level as 550 and then the core hardness level as 439. Hence the gear is undergone a carburizing hardness. So the surface will be more harder when compared to the core hardness. And then the case depth is 0.63 mm and it is normal. And then the microstructures what we can see in this failure is martensite and then austenite. These are the microstructures, and the white particles in this microstructure are austenite, and then the black particles which we can see are the martensites. And this is the crack which occurred in our gear. This is the photograph of the gear too, and then here the major part is pitting and spalling as done.
So as by the micro examination, we can see that the crack initiation part
and those are the crack propagations in the curves, and we can see the cracks occurred, crack marks occurred.
This is the pitting, and then we can see the destructive pitting occurred in the gear, and the spalling has taken this side. These are the major failures occurred in this gear.
As already said, these are we can see clearly in this image. That's the crack initiation part. These are the crack propagations, and those are the crack marks appeared.
So this photograph is nothing but this semi-image, scanning electron microscope image, where it is taken at the range of 5000x, right? Okay. So
As a conclusion, the composition, microstructure, and the hardness from the fatigue are all correct. So the fatigue leads from the misalignment of the metal as because of load concentration, which like Kishore said, the cyclic loading which they are being. So this is the conclusion. Thank you.
thank you.